Now let's try to solve a problem that involves the thermodynamic potentials as well as entropy, heat, work, and internal energy. So you have here 1.5 moles of an ideal monoatomic gas at 300 Kelvin, and it has an initial pressure of 15 atmospheres. Okay, so 1.5 moles, 15 atmosphere, 300 Kelvin. Now, it's allowed to expand to a final pressure of 1 atmosphere. So, ang kailangan nating i-calculate dito are the following: internal energy, enthalpy, Gibbs free energy, change in entropy, change in Helmholtz free energy, heat, tsaka si work. And we will do that for the two cases. Number one, if the expansion is isothermal and reversible. And number two, if the expansion is isothermal but against a vacuum. So what we will do first is we will tabulate the given condition. So initial tsaka final. So you have initial versus final condition, and I'm talking about the number of moles, pressure, temperature, and volume. So for the number of moles, constant yan, 1.5 moles, initial and final, conservation of mass yan. Pressure is 15 atmosphere initially, pero gusto natin siyang expand to 1 atmosphere. Temperature is constant, 300 Kelvin, 300 Kelvin. So what you will do is you have to compute the volume. You can use the ideal gas equation kasi we're assuming here, or it's stated that the gas is ideal or perfect. So if you will compute the volume using the perfect gas equation, so ang makuha mo is 2.46 liters initially, and the final volume will be 36.95 liters. Kayo na bahalang mag-compute niyan. So let's consider the first question. Kapag isothermal and reversible yung process. Okay. So since isothermal yung process natin, remember that both the internal energy and enthalpy is a function of change in temperature. It's a function of temperature. No, kasi kaya nga delta U equals CV dt for ideal gas, delta H is Cp dt. So may dt, may change in temperature dun sa formula niya. But since isothermal to, so ang lalabas, delta U will be equal to 0 and delta H will be equal to 0. So meron na tayo agad dalawang sagot. Next, we want to calculate the work. If you recall, work is minus P dV, diba? Integral. So let's do that. Negative. So integral of negative P, but P is what? nRT over V. Tapos meron kang dV. Okay? Integrating it from initial condition to final condition, magiging minus nRT ln of V2 over V1. Okay? So yan yung work natin. So let's substitute what we have. N is 1.5 moles. And then you have R, which is 8.314 joules per Kelvin mole. Hindi ko na isusulat. Temperature is 300 Kelvin. Then you'll have here ln of 36.95 yung na-compute kanina divided by 2.46. So ang sagot na lalabas dito is that work is equal to negative 10.14 kilojoules per mole. Now, remember lang that delta U is equal to Q plus W according to the first law of thermodynamics. Okay, but delta U here is 0 according to our answer earlier, right? So, therefore, yung Q is just the negative of your W. Okay? So, ibig sabihin, Q will be negative of negative 10.14, our answer earlier. So, heat will be 10.14 kilojoules per mole. Okay, so isunod natin ngayon yung kay entropy. Now remember, there are two entropy general equations that we discussed last time that we derived. Ito yung dalawang yon, no? Now, since perfect gas yung ating gas, mayroon diyang makakancel. So just remember na for an ideal gas, this term right here for the first equation is just 0. And yung pangalawang equation naman, 0 naman tong partial v with respect to v at constant t. Okay? Furthermore, since isothermal yung condition natin, mawawala tong Cp dt over T dito sa first equation, and ganoon din dito sa second equation yung Cv over T dt, isothermal. So ano na lang matitira, or what will happen to the equation is that it will reduce to, so yung una, magiging ano siya, ang matitira is that ds equals negative v over T dp. Okay? Yung pangalawa naman, ano mangyayari? So it will reduce to P, so ds is P over T dv naman. Okay? So we have here two equations. Alin dyan yung gagamitin natin? So actually, you can use any of these two equations, right? Tawagin natin yung isa as equation 1, yung isa naman ay equation 2. So let's consider equation 1. Okay? Yung ds equals minus v over T dp. Okay? Since perfect gas yung meron tayo, yung volume pwede mong express as nRT over P. Okay? nRT over P. Since meron kang temperature sa denominator, makakancel lang yan. So dp. Okay? And next is you have to integrate from initial condition to final condition to get the entropy. So lalabas dyan is negative nr, okay, ln P2 over P1. What is N? 1.5 moles. R is 8.314. Ln of P2 over P1. Do you have these values? We tabulated a while ago. So P2 is P2 is 1, P1 is 15. So 1 over 15. Okay, 1 over 15. So ano yung magiging sagot for entropy? So that will be 33.8 joules per mole Kelvin. Okay, so yan na po ang ating value ni change in entropy for the system. Okay, now what if I use equation 2 instead? No, equation 2 ang gamitin natin. So equation 2 is ds equals P over T dV. Okay, expressing P as nRT over V, magiging nR over V dV yan. Okay, kasi ideal gas siya. Integrate natin from initial to final condition. Magiging delta S equals nR ln of V2 over V1. Okay? N is 1.5. R is 8.314. ln of V2 over V1. Ano yun? V2, 36.95. V1 is 2.46. So, ang lalabas dito will be also 33.8 joules per Kelvin mole. Okay, so ibig sabihin, equivalent lang, parehas lang yung dalawang equation na to. Okay? And in fact, yung relation na to, this one, and this one, they are related. Ibig sabihin, pwede mong convert yung pressure dun sa volume. And that's because of Boyle's law. However, ang pinakamadaling paraan para i-solve or i-calculate si entropy is yung basic equation niya, right? Which is Q over T. So what is Q over T? Q is, we have that, right? Yung sagot kanina na 10.14. So 10,140 divided by 300 Kelvin yung ating temperature. So ang lalabas dito is the same, 33.8 joules per Kelvin mole. Walang kahirap-hirap. So we're done with enthalpy, internal energy, QW, tsaka entropy. So ang natitira na lang is yung mga free energy functions natin. So let's proceed with Helmholtz. Helmholtz free energy. Okay. So how do we exactly calculate this? So ano ba yung definition ni Helmholtz or yung change in Helmholtz free energy? Kung babalikan natin yung lecture, minus PdV, okay, minus SDT. So all you have to do is differentiate yung definition na mathematical ni Helmholtz. Okay, ang maganda dito, you will be able to cancel minus SDT right away. Kasi nga, isothermal yung ating condition. So, matitira dun sa Helmholtz function equation is minus PdV. So, dA is minus PdV. Okay? Ideal gas to eh. So, ibig sabihin yung P we can express as minus nRT over V dV. So, yun yung dA natin. Integrate natin. Okay, from 1 to 2. 1 to 2. Ang lalabas na delta A is negative nRT ln of V2 over V1. And we have seen this a while ago. That's exactly the expression also for the work done, no? Which is this one. Okay? So, yan din yung sagot, 10.14 negative. So, delta A is negative 10.14 kilojoules per mole. Of course, I already converted it to kilojoules per mole. Pero joules per mole talaga dapat yan. And lastly, si delta G, right? Ano bang definition ni Gibbs free energy? Or the change in Gibbs free energy, that's dG equals minus SDT plus VdP. Okay, again, isothermal tayo, so mawawala yung isang term. This will just be 0. So the equation for dG will be reduced to VdP. Okay? Ideal gas, so we can express V as nRT over P. Then we have dP here. Integrate from initial to final. Delta G is equal to, therefore, positive nRT ln of P2 over P1, which we have also seen kanina lamang. And that is also, kasi kung titignan natin, we can just replace this as negative nRT ln. Ginawa kong negative, so yung pressure, pwede na siya maging volume. V2 over V1 this time. Not V1 over V2 kasi inverse naman yung relationship ni pressure and volume according to Boyle's law. And that is exactly what happened also kanina lang kay Helmholtz, right? So this is the same expression. So therefore, kukopyahin lang din natin yung sagot kasi ganoon din lang lalabas. Delta G is equal to negative 10.14 also kilojoules per mole. Or, pwede rin gamitin mo yung definition ni Gibbs free energy na delta G is equal to delta H minus T delta S. Pwede rin yan. Kasi si delta H, 0. Diba? Nakuha natin kanina si delta H as 0. So, ang magiging lalabas na delta G is minus T delta S. Ano ba yung temperature natin? 300 Kelvin. Yung delta S na nakuha kanina is 33.8. So, ang lalabas dito will be 10,140 joules per mole, or negative yan, no? Negative 10.14. So, parang pareho lang dun sa nakuha natin kanina. Kilojoules per mole. Okay? In other words, marami kayong equation ng pagpipilian. Okay? At your disposal, maraming pwedeng pagpilian. If you don't want to memorize, you can derive. Okay, hindi pa tayo tapos kasi we have completed all thermodynamic functions for letter A. But for letter B, di ba, ang sabi dun sa letter B, paano kapag isothermal pero against vacuum? So, just to give you a refresher, kapag against vacuum, yung expansion, ito yung tinatawag nating free expansion. Okay. Free expansion. Walang energy requirement. So, kapag free expansion, kung naaalala nyo yung kay first law of thermodynamics, delta U is 0. Delta H is 0. Q is also 0. And work is also 0. But how about si entropy? How about Gibbs free energy? How about Helmholtz free energy? Will they have a value? So, kayo na bahala. Alamin ninyo kung may value nga ba sila. And kung meron man, what will be their value? How do you calculate those free energy functions as well as entropy?